This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on graphing exponential and logarithmic functions. Our first example is f of x equals 2 to the x. We have a base of 2 and exponent of x. When the exponent is a variable, we call that an exponential function. So indeed, 2 to the x satisfies that condition. So we're going to make a table of values. We're going to choose values for x and find corresponding values for y. So if x is 0, y is 2 to the 0. Anything to the 0 power is 1. So our first point is 0, 1. If x is 1, y is 2 to the first, or 2. If x is 2, y is 2 to the second power, 4. If x is 3, y is 2 to the third power, 8. Then I went to a negative number. So for negative 1, y equals 2 to the negative 1 power. If we have a negative exponent, that bounces downstairs. That means 1 over 2 to the first power, or 1/2. If x is negative 2, we have 2 to the negative 2 power, which is 1 over 2 to the positive 2 power, or 1/4. So we have a collection of points, 1, 2, 3, 4, 5, 6 points that are going to help us establish this graph. Here's the seventh. If x is negative 3, 2 to the negative 3, 1 over 2 to the third is 1/8. So graphing all of those points, you can see how this behaves. So the graph is going to grow to infinity. It's going to get as high as you want, but you'll notice it's stabilizing on the x-axis. So that tells us something about a horizontal asymptote, which we'll have, which will be the x-axis, as well as the domain and range. So the domain, all allowable x values, we can plug any x value into this that we want. The domain will be everything, but the range, notice all of the answers are positive. So the output will just include positive numbers. So again, there's our picture. The horizontal asymptote is the x-axis. You'll notice how the graph is heading down, getting closer and closer to the x-axis. Horizontal asymptote is the x-axis, y equals 0. Domain, all reals. We can plug in any number for x we want, but the range will never actually hit 0. 2 to the negative 100 power is 1 over 2 to the 100th. Awfully close to 0, but never actually hits 0. That's why it's a round bracket. And then it goes to infinity. Will grow as fast as we want it to grow. So that's the function f of x equals 2 to the x. Let's move that a little bit. Or actually, let's take its inverse. So g of x is log base 2 of x. How does that relate to 2 to the x? It's an inverse function. So what we say then is, given f of x is 2 to the x, the inverse, f inverse of x, is log base 2 of x. They undo each other. So let's remember that to find an inverse, x becomes y and y becomes x. That is, in essence, our definition of an inverse. So we had this chart of values in the last example. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, etc. If I want to graph f inverse, I have to make x, y, and y, x. So you'll see 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. 3, 8 becomes 8, 3, etc. This is the inverse function. This is y equals log base 2 of x. So we can graph these to get a feel for what that looks like. So there's our table of values, graphing those points. 1 on x, 0 on y, 2 on x, 1 on y, 4 on x, 2 on y, 8 on x, 3 on y, a half on x, negative 1, a quarter, negative 2, an eighth, negative 3. So if we were to connect all these, you'll notice it's asymptoting this time to the y-axis. As we head this way, the dots get closer and closer to the y-axis, but never actually get there. So we'll have a vertical asymptote this time, and this is going to grow slowly, but it's going to still grow to infinity. So our vertical asymptote is the y-axis, which is x equals 0. The domain, notice we're not allowed to plug in 0. The function never actually hits 0. So the only x values were used for this log function, and in fact, logs are only defined for positive numbers. So our domain is from 0 to infinity. Our range, it'll go as low as you want to go. It gets lower and lower towards the y-axis, and then it grows and grows and grows and grows as big as it wants. So our range here is all real numbers. Our range is negative infinity to infinity. So we just graphed y equals log base 2 of x. How would this be different? We're going to have a shift. The x minus 3 tells us to shift. The negative 2 tells us to shift. So of course, 3 places to the right for f of x minus 3, 2 places down to add negative 2. So this was our previous graph. Our previous graph here were in the red dots. So you'll notice if I take this red dot over here 3 places to the right, 1, 2, 3, down 2, 1, 2. So this corresponds to that red dot. This one 3 places to the right, 1, 2, 3, down 2, 1, 2, corresponds to that red dot. I'll do one more here, 1, 2, 3, 1, 2. So in each case we took all of the red dots that was log base 2 of x, recognizing we had to shift this 3 places to the right and 2 places down, and we get this new graph of blue dots. Now before I go on, think about where the vertical asymptote will be. Think about what the domain will be for this function of blue dots. So again, there's our original red dots, and here's shifted 3 places to the right and 2 places down with it connected. So as we said before, you can only take logs of positive numbers, so x minus 3 has to be positive. If x minus 3 is positive, x will have to be greater than 3. And you can see that we never hit this function here for any number less than 3. So our domain is beyond 3. 3 is no good because you cannot take log of 0. But the range, again, everything. It'll get as low as you want it to get this way. It'll get as high as you want it to get this way. So in the y values, we'll hit all of them, but the x values will never hit an x value less than or equal to 3. Vertical asymptote here. Vertical asymptote at x equals 3. And domain again, 3 and beyond, above 3. So not including 3. We can't take a log of 0. So 3 to infinity, and the range here, all of the y values get hit. So that's what we have by taking the graph of log base 2 of x and doing a shift, 3 to the right and 2 down. We're going to try to graph this a little differently. Rather than shifting it, which we could do, we're just going to go ahead and create a table of values. So we're going to rewrite this as y equals 2 minus log base 3 of x minus 1. And we're going to go ahead and subtract 2 from both sides. Y minus 2 is negative log base 3 of x minus 1. I'd like to have the log base 3 to be positive, so I'll multiply both sides by negative 1, multiply this side by negative 1, multiply that side by negative 1. So negative 1 times y minus 2 is negative 1 times negative log base 3 of x minus 1. Of course, on the left, distribute the negative 1. Negative y plus 2 equals negative 1 times negative 1, positive log base 3 of x minus 1. Our goal is to create a table of values and then to graph. Can we do that? I want to rewrite this with log 3 on the left, just a little easier for me to think about. So now I have log base 3 of x minus 1 equals negative y plus 2, just switching right side for left. Now what does this mean? The base of the log is 3. 3 to the exponent, negative y plus 2, equals x minus 1. Always start with the base. The answer is an exponent equals the argument of the function. So 3 to the negative y plus 2 equals x minus 1. Now I'm not going to solve for y here, but I am going to solve for x. So if I add 1 to both sides, you can see that x equals 3 to the negative y plus 2. And my goal is to make a table of values. So I will plug in values for y and see what the corresponding values are for x. So we have x is 1 plus 3 to the negative y plus 2. And I don't need this y equals 2 to the x. I'm going to go ahead and eliminate. If y is 0, plugging in 0 here, 1 plus 3 to the negative 0 plus 2, which is 1 plus 3 to the second. 1 plus 9 is 10. So x is 10 when y is 0. Next up, we're going to change y and find out what x is. If y is 1, we're going to replace that y with 1, 3 to the negative 1 plus 2. So 1 plus 3 to the 1. 1 plus 3 is 4. So our next point is 4, 1. Then we're going to let y be 2. So 1 plus 3 to the negative 2 plus 2. 1 plus 3 to the 0. 1 plus 1 is 2. So our next point is 2, 2. If I let y equal 3, we have to go to 3 to the negative 3 plus 2. So 1 plus 3 to the negative 1, 1 plus a third, which is 4/3, or 1 1/3. And I went ahead and I used negative 1 as well. The negative of negative 1 is positive 1. 1 plus 2 is 3. 1 plus 3 to the third. 3 times 3 times 3 is 27, plus 1 is 28. So our last point here is 28, negative 1. That's certainly going to be difficult for us to graph. But we have our table of values. X is 10, y is 0, x is 4, y is 1, x is 2, y is 2, x is 4/3, 1 1/3, y is 3, x is 28, y is -1. So there are all of our values on the table. The x value here is g of x, 2 minus log base 3 of x minus 1. So let's go ahead and graph these points and see if we can identify the behavior. So it seems to be coming down this way. Do you see a vertical asymptote? And the 1 1/3 is supposed to kind of give you an indication of how this is going to behave. And then 28, -1 is down here, so it continues dropping. And it drops very slowly, but it continues to drop. But it starts going up pretty fast. So we will indeed have a vertical asymptote. The vertical asymptote will be here at x equals 1. And let's think about domain and range. So again, here's our function once we've actually graphed it. There's our points. And our vertical asymptote is indeed at x equals 1. Now our domain, we are not allowed to take logs of negative numbers. So x has to be larger than 1. Our domain is 1 to infinity. Range gets as large as you want it to get. And it goes negative. It takes a long time to get there, but it gets as large negative as you'd want to get. So indeed, the range is -infinity to infinity. All right, let's take a look at another question here. F of x is 3 plus 2 to the x minus 1. I'm going to do this by plugging in values. If x is 0, 0 minus 1 is -1. 2 to the -1 is a half. 3 plus a half is 3 1/2. 1. 2 to the 1 minus 1 is 2 to the 0. 3 plus 1 is 4. 2. 3 plus 2 to the 2 minus 1. 2 minus 1 is 1. 3 plus 2 is 5. 3. 3 minus 1 is 2. 2 squared is 4. 3 plus 4 is 7. -1. 3 plus 2 to the -1 minus 1. And that would be a mistake. So I guess I'm stopping. Back again and fixed. 2 to the -1 minus 1 is 2 to the -2, which is 1 over 2 squared, or 1/4. So 3 plus 1/4 is 3.25. So we've got all of these values. 0, 3.5, 1, 4, 2, 5, 3, 7, -1, 3.25. So we can go ahead and we can graph those and see what they look like. So we have our exponential function heading up this way. Where is the horizontal asymptote? Looks like it's getting closer and closer to 3. Indeed, as we graph the function, you can see that's the behavior. Horizontal asymptote at 3. Domain, all real numbers, yes. Range, we only have numbers larger than 3. 3 is this, we can't quite get to 3, but anything bigger than 3 we can get to. So our range will be from 3 to infinity. So there's our horizontal asymptote at y equals 3. Domain, everything, range, y values from 3 to infinity. Now, can we do something with this function? Can we graph the inverse? So I've graphed f. Can I graph f inverse of x? How do we do that? We replace x with y, y with x. So there was our original table. Let's replace x with y, y with x. So 0, 3.5 would become 3.50. 1, 4 would become 4, 1. 2, 5 would become 5, 2. 3, 7 becomes 7, 3. -1, 3.25 would become 3.25, -1. X becomes y becomes x. Now we graph these values, and they'll be the graph of the inverse function. So there was the original function, and here's these dots. 3 1/2, 0, you see that. 4, 1, you see it. 5, 2. 7, 3, 3 1/4, -1. So this thing is going to have a vertical asymptote at 3. So there's our two graphs labeled, f of x there, f inverse of x. F inverse of x has a vertical asymptote at 3. F of x had a horizontal asymptote at 3. No surprise. Now, what's our issue for f inverse? Can we compute it algebraically? So f of x is 3 plus 2 to the x minus 1. Replace f of x with y. And then to find an inverse, we switch x and y. So we get x equals 3 plus 2 to the y minus 1, and then our goal is to solve for y. To do that, we're going to have to use some logs eventually. So we're starting with this. Let's subtract 3 from both sides first. So x minus 3 is 2 to the y minus 1. Let's hit both sides with a natural logarithm. So natural log x minus 3. is natural log 2 to the y minus 1. Pull this y minus 1 exponent down front. Log x minus 3 equals y minus 1 log 2. Distribute y times log 2 minus 1 times log 2. Then I have to solve for y, so I'm going to need to add natural log 2 to both sides. So adding natural log 2 to both sides, I get natural log x minus 3 plus natural log 2 equals y log 2. My goal is to solve for y, divide both sides by natural log 2. And what's left is this, natural log x minus 3 plus natural log 2 divided by log 2 is y. And that is f inverse of x. We've solved for y. So f inverse of x compared to this f is going to be natural log x minus 3 plus natural log 2 over natural log 2. You could have used log base 2 instead. I prefer to use natural log because it's easier to use graphing utilities and calculators and such. And that will conclude this lesson.